All right, let's dive into something that, honestly, powers a huge chunk of the modern web: JSON Web Tokens. You've probably heard the acronym JWT thrown around, but what are they, really? How do they work? And more importantly, why should you care? Well, let's break it all down. So let's start with a really basic question. How do websites remember who you are after you log in? You type in your password once and then you can click around from page to page without having to log in again. This is actually a huge challenge because the web is fundamentally stateless. It has zero memory. Every single request you make is like a brand new introduction, so we need some way to remind the server, hey, it's me again. The old school way to solve this was with session tokens. Think of it like a coat check at a fancy restaurant. The server holds onto your coat, that's all your user info, and just hands you a little ticket. The modern way, with JWTs, is totally different. It's more like a signed, laminated VIP pass. The pass itself has your picture, your name, what level of access you have, everything you need. The key difference? The server doesn't have to remember a thing about you. So yeah, we're talking about the web's fundamental memory problem. Now that classic coat check model, it works perfectly fine for a simple website running on a single server. But in today's world of massive distributed apps, that model starts to fall apart. And, well, here's why. Just imagine this. You log in and server A gives you your coat check ticket. Great. But your very next click gets sent to server B. Server B looks at your ticket and has no idea what it is. It's like, nope, don't have your coat here. This forces developers into building these really complex shared memory systems, which, trust me, can become a huge bottleneck. And this is where JWTs come in to save the day. They are a truly modern solution, designed from the ground up for today's scalable, stateless web. They're that VIP pass that every single server in the entire system can look at, instantly recognize, and trust. So what is a JWT, really? It's a compact, standardized way to securely send information as a signed JSON object. But the most important word on this slide is self-contained. Everything the server needs to know about you is packed right there, inside the token itself. Now, when you actually look at a JWT, it doesn't look like JSON at all. It's just this long, kind of crazy-looking string. But you'll notice it's separated by 2 dots. And those dots break it into 3 distinct parts: the header, the payload, and the signature. First up, you've got the header. This is basically just metadata for the token. It's a little JSON object that says, hey, I'm a JWT, and here's the cryptographic algorithm we're using to secure me. Then, this whole thing gets encoded into that string you see. The second part is the payload. This is the good stuff. This is the heart of the token. It's another JSON object, and it contains what we call claims, which is just a fancy word for pieces of information about the user. Things like their user ID, their name, maybe their permissions, and when the token should expire. Okay, stop for a second, because this is the single most important security point you need to understand. The payload is encoded, which is not the same thing as being encrypted. Anyone who gets their hands on this token can easily decode it and read everything inside. It's like a postcard, not a sealed letter. This means you should never, ever put sensitive data like passwords in the payload. So you might be thinking, if anyone can read it, where is the security? It all comes down to part 3. The signature. This is the tamper-proof seal. It's created by taking the encoded header, the encoded payload, and a secret key that only the server knows, and running them all through a cryptographic hashing function. This is what makes the token trustworthy. Okay, let's see how this all flows together. You log in, the server checks your username and password, and if they're good, it creates a signed JWT just for you. It sends that token back to your browser. Your browser then tucks it away and includes it in the header of every single request you make from then on. When the server gets a request, it just looks at the signature, verifies it's legit, and lets you in. That's it. Simple and completely stateless. Now, I really want to double down on this one point because it is so important. The signature is everything. I'm not kidding. It is the absolute cornerstone of JWT security. Without a valid signature that the server can trust, the whole system just completely falls apart. Here's that analogy again, because it's perfect. Anyone can read the address on an envelope. That's your header and payload. But it's the unbroken wax seal, that's the signature, that proves the letter came from who it says it came from, and that no one has opened it and messed with the contents. So what this really means is that this cryptographic link is basically unbreakable without the server's secret key. If an attacker tries to change even one character in the payload, like changing a claim from add as admin false to true, the signature they generate won't match the original. The server will spot the mismatch instantly and just reject the token flat out. Okay, so JWTs are powerful, they're modern, they solve a real problem, but, and this is a really big but, all that convenience comes with a dark side. If you're not careful about how you implement them, they can open up some truly scary security holes. Let's talk about one of the most famous JWT attacks. It's called the alg.none attack. See, the official JWT standard actually allows for an unsecured JWT, where the algorithm in the header can be set to none. It's basically a way of telling the server, hey, there's no signature on this thing, just trust me. It's an honor system. So you can probably guess how this works. An attacker gets a token, decodes the header, which anyone can do, remember, and they just change the algorithm parameter. They find HS256 and they just replace it with none. After they change the header, they just delete the signature part of the token completely. Now, if the server is poorly configured and doesn't check for this, it will see the none algorithm, shrug, and say, okay, I guess I don't need to check a signature, and it accepts the token. And just like that, an attacker can make themselves an admin. Game over. And honestly, that's just one of many potential dangers. Attackers can try to guess weak secret keys, like password 123. They can use other clever tricks to confuse how the server verifies things. The bottom line is, even tiny mistakes in how you implement JWTs can lead to massive security failures. Look, I know this all sounds a little scary, but it really doesn't have to be. As long as you follow a few clear, well-established best practices, you can get all the benefits of JWTs and keep your application locked down tight. So here is your security cheat sheet. First, always use a long, strong, totally random secret key. And always put an expiration date on your tokens. Second, your server code should have a whitelist of exactly which algorithms it will accept, and you should never, ever allow none. And finally, always, always, always transmit tokens over a secure HTTPS connection. And that really brings us to the big final question. JWTs offer this amazing stateless convenience, and they take a huge memory load off our servers. But as we've just seen, that convenience has a really sharp edge. It forces us to ask, are we accidentally trading real security for that convenience if we're not paying close attention? It's something every single developer needs to think about. Thanks so much for watching.